Today most of the rockets use liquid propellant, although solid fuel is being added on the sides of some rockets to give it an initial boost and an additional thrust to lift off from the ground. This addition of solid propellant from the sides of the core stage is called solid rocket boosters, or SRB. The most common liquid fuel used today is RP-1, or Rocket Propellant-1, and hydrogen, and many of the upcoming rockets will be using methane, like Vulcan, Starship, and New Glenn. Starting with RP-1. RP-1 is a hydrocarbon fuel. RP-1 is a refined form of jet fuel, and jet fuel is a refined form of kerosene, which itself is derived from petroleum. RP-1 gives lower specific impulse than liquid hydrogen, but is far denser than hydrogen. Specific impulse is the measure of how efficiently a rocket engine produces thrust. You can think it as the mileage of a car. To understand it even more, imagine that you have 1 kilogram of propellant. For how many seconds can the engine produce a thrust of 9.8 Newton with that much of propellant? A propulsion system with a higher specific impulse uses the propellant more efficiently, which means you have to carry less propellant for achieving a given delta V. Delta V is the change in velocity of the rocket from zero on the launch pad to the desired velocity you want to achieve. In physics, delta means change. RP-1 have specific impulse of around 270 to 360 seconds, while hydrogen gives a specific impulse of 370 to 465 seconds. RP-1's density is around 810 grams per liter, and that of hydrogen is around 70 grams per liter. Higher density means higher energy in less volume, which will result in smaller fuel tanks. RP-1 was being used in the first stages of Saturn V, Saturn I, Saturn 1B, Titan I, and Energia. Falcon 9 and Falcon Heavy uses RP-1 in all the stages. Soyuz, Atlas, and Delta I, II, and III also used RP-1. RP-1 has the advantage of high thrust due to the presence of carbon atoms in it, which is heavy. High mass shooting out of the exhaust means high thrust, but low delta V. That's why it is generally used in lower stages of rockets, where you want to lift your heavy vehicle off the ground. Once you have liftoff and achieved some speed and altitude, then we use hydrogen to attain high speed to enter into an orbit around the Earth. But this is not compulsory. For example, SpaceX uses RP-1 in lower as well as upper stages. And there are some other options too, like hypergolic propellants, which ignite as soon as they come in contact to oxidizer, like UDMH and N2O4. So, you have to decide which propellants fulfills the aim of the mission.